Hi, my name's Angus Robinson. I'm the Product Marketing Manager at Anritsu, and I'd like to show you today two new products that we've introduced here at the CTIA show in Las Vegas. Both of them are remote spectrum monitors, but they're targeted at very different markets. This is an outdoor 6 gigahertz unit, and it's designed for people who want to monitor a wide geographic area to see all the spectral activity that's going on at any moment in time. It's in an IP67 case, which means it can be left outdoors for years at a time. It's weatherproof, and you connect to it over the Ethernet from a central location. And from that location, you can be monitoring many of these remote spectrum monitors at the same time to give you an overview of all the spectral activity that's taking place in a given geographic region. So this is of interest to government agencies and people who need to police and monitor the spectrum, even in a local area or over a wide area. It's got a built-in web server, so we can connect up with our PC to view the spectrum. Here we're seeing a couple of LTE signals that are at the show here. But you can also control it with regular Skippy commands or an application that we call PC Vision software that allows you to control and track and log the output from these spectrum analyzers over a very long period of time. The second unit I've got here is also a headless spectrum analyzer. This one's targeted for indoor use and typically for monitoring expensive spectrum that a network operator might have purchased. So if you spend billions of dollars buying spectrum, you want to be sure that you're the only person using that. You want to be able to police it. And this spectrum monitor here with 12 or 24 RF inputs allows you to monitor all the sectors at a cell site for one or more frequencies. So that's why we need the multiple inputs. And again, from a remote location, you can view the spectral activity at that site. You can track for interferers, you can track for illegal users, you can police and monitor and keep sure that your asset is well protected.
Hi, my name is Emilio Franchy. I'm a Senior Product Manager for Anritsu Corporation, and we are introducing our new CPRI RF option for our BTS master. What we are taking is basically through the optical fiber, we are pulling the IQ data off between the RRU and the BBU and converting that to a spectrum analysis. The key thing here is for a lot of carriers, they don't want their technicians to climb towers to troubleshoot problems like interference or PIM, so they want a way to test at ground level and reduce our OpEx cost. So this is one way where they can actually tap into the fiber and then look at the spectrum through here. We do have a couple different measurements on here, our CPRI spectrum and our spectrogram. So the spectrogram is typically used when you are looking for troubleshooting interference problems for over, say, 24 or 48 hour time period when you don't know when it's happening. You know you have problems, but you want to then collect data over a specific period of time. And you can do that with the spectrum analyzer. And then back on the spectrogram, we added some features that were requested by some of our key customers that are typical of troubleshooting. So I'll take a step back. CPRI's got some limitations. With CPRI, you only get a specific amount of data, so you get the carrier and about a little bit 50% beyond of, we'll call it dummy data. It's not real. It's really, you're looking at in-band interference problems. And it's a relative measurement. It's not fixed, so it's not absolute. So you don't have a specific frequency. You don't have power levels. But a lot of customers want to be able to kind of use this as a traditional spectrum analyzer. So one of the things we did is give them the ability to offset their signal. Like if they find an interferer, they can move it this way. We actually blank out the section that's not real data, so there's no confusion. And then we also allow them to span down to zoom in on the signal of interest. So you can see that there on the screen. And you can just bring it right back with really quickly, recenter it, and you have it right back where it started. Again, same thing with the markers. You can do a marker to turn on a marker, do a peak search, and marker to center frequency like a traditional spectrum analyzer. So right back there. So in a sense, the hardest thing that a customer is going to, or user is going to have is configuring the link. It's a pretty complicated setup. We have added some presets, so we're supporting Alcatel-Lucent and Ericsson radios, and they can quickly configure it by using the pre-configured links. If you have to change a few parameters, you can go to the advanced menu, and you have choices of looking at your IQ bit width length, your antenna containers. There's a lot of new terminology for the RF guys because of this, the optical information. We also have a auto detect function. So if you at least know who your vendor is, then you can just hit a start button, and then it will actually figure out the line rate very quickly, and then start populating some of the possible options that you can have, and then you can click on that to go directly to the actual radio signal that you're looking for. So it simplifies it a little bit, and for folks that don't have a lot of information, and most of the time that I've gone in the field, a lot of the technicians today don't know a lot of these parameters. So this is probably a real functional or useful tool for them.